discussing a paper that deals with video to robot action models. This is one of the crucial breakthroughs that we think is necessary for a comprehensive robotic solution. We believe that video to robot action is actually only the first step. Generative video to robot action then will be the actual breakthrough that is necessary to get a general solution for robots, whether it's in humanoid form or not, that will be seen. But we believe that the kind of data that is necessary and the kind of training and the kinds of training runs that are necessary to have a general robot be able to be launched require these types of steps. So this paper is a first step. The reason we picked it is because it really, I think, comprehensively solves the problem. It goes through the pipeline. So it's not just video to robot action is certainly one of the big problems, but you also need a data standard. You need a way to translate the data, whether it's from YouTube or other types of data sources, into a format that is then applied towards robot action models. And then you need a training run that is comprehensive in a sense that it can handle all these data formats. This is not even on podcast. It's October 14, 2025. This is Crimdelco. For the day, the fund is down 2.9%. The market is down roughly 20 basis points. For the year, we're up 13%. The market's up 13%. We are in line with the market. So this paper, links in the show note, describes the problem and a potential solution to training from video. So robots training from video. Elon Musk has mentioned back in May in a CNBC interview that is the way Optimus is going. So there's a couple of things that we believe will happen and will definitely, bring robotics to the point where it can be used in a similar way like FSD is being used today, the first real-world robotics solution by Tesla. So first, we need data. And the way we will get data is from video. So this paper discusses a particular problem, which is you have, let's say you play video games and you watch people play video games, and then you infer from those video games actions. The paper generalizes from video games towards any kind of robot action. What that means is, and this is in our opinion, this is the crucial innovation of the paper, which is that you take, for example, a forward action in a video game. So you click a mouse forward, and then you abstract that forward in such a way that a robot can learn that it needs to go forward, not just in terms of a mouse click forward, but just forward. And then, of course, it has to figure out how to go forward based on its own embodiment. The same applies to something like grasp a bottle. So grasp something, and then that something could be a bottle or it could be something else. So this abstraction, in my opinion, is the key breakthrough in this paper, or the key contribution of the paper. We're not a technical podcast, so we're not going to describe the technicalities of the solution of the authors. Read the paper for that. But I think in general, on the sort of big picture view that we see ourselves here is, first, there are solutions for general robotics, and the industry is working towards those solutions. Whether Tesla will be a winner or not, that's a different question. But what's important is that we have solutions. This is not just some utopia. And we spoke about the bitter lesson applied to everything just recently. And this is a good example of how you can apply the bitter lesson to robot learning by leveraging data and general compute and abstraction. Another thing you need is, in order to have a general robotics solution, you need a reinforcement learning solution for this problem, because the way you're going to train these robots is on video data, but they're going to pursue goals. and they're going to learn tasks while pursue goals. So clean my apartment. For that, it needs to understand how to go forward. It needs to understand how to sweep a floor. It needs to understand how to clean. It needs to understand all these things. The tasks will be learned within the context of pursuing a goal. And I think as a final note, we just want to say that it's important that we have advancements in generative AI, such as Genie, such as maybe Nano Banana. These are two Google projects. Tesla's working now on a world model for video games, which is the same idea. XAI. So we want to build world models where robots can iteratively learn how to interact with physics and then apply that to the real world. This is the way we see robotics evolve, and this paper is a crucial step into that direction. Learning from video, like we said, it's only the first step, actually. We believe that generative AI will be the actual breakthrough because you can have a lot more runs, you can have a lot more scenarios running through. But this, as a framework, I think this paper is very useful. One last thing I wanted to mention is the inverse dynamics model, which is, of course, very important here. That is, you learn actions from observations. So you see, let's say, you see a robot, and then you see a video, and in the video, a human is at point A and then at point B, and the robot infers an action from that. That's inverse dynamics, that it has to actually walk from A to B. So that's the idea of inverse dynamics, which is also part of the application in this particular paper. Thank you.